integration by parts. So this is a repeat of the first two examples from the previous video. I'm not going to use the formula, this one. I'm not going to refer to that. So we have in the correct order. So x is on the left, it goes on the left. E to the power of 2x is on the right, it goes on the right here. Differentiate, integrate, we divide by the coefficient of x, and then we multiply these two together, so we're cross multiplying this way to get these terms, and then it's always minus the integral of, and then you're multiplying these two here. So now you integrate the bit in green, add on the constant, and you're done. To cut down on the working out even further, this u equals and dv by dx equals, I could eliminate those as well to get this. So I've done that for example 2. So 3x on the left, cos x on the right. Differentiate, integrate, and then cross multiply this way here, 3x sine x, minus the integral of, and then multiply these two, do the integration, and we're done. Not much working out really. Example 3, so 3x, the x term should be on the left, which it is, so the x is on the left, the x term, and then we've got the e to the power of x term on the right. When you integrate e to the x, you get e to the x again. When you differentiate 3x, you get 3. So now we have this. So multiply these two here. Then it's always minus the integral of, and then you multiply these two. And now we have to integrate here. And what you'll see is that we had the product of two functions of x here. Now we've reduced that to a single function of x here. And then we do the integration and add on the constant. Example 4. So I did say that you keep the x term or the x to the power of term on the left. That's true unless you have a log function. If you have a log function, then the log function is the one that should be on the left and any other term on the right. So we're starting with this. So the log term is on the left, differentiate to get 1 over x, x cubed is on the right, integrate, multiply this way to get these terms, minus the integral of, and then multiply this way, and you can simplify before writing the terms down. So if you're multiplying these two, x to the power of 4 multiplied by 1 over x, you'll get x to the power of 3, and there's a quarter here that we need to multiply by. So again we now have a single function of x, whereas we started off with the product of two functions of x. So we have simplified. Now we just need to integrate, add on the constant. Using integration by parts more than once. Okay, so the x to the power of term is on the left, so the order is correct. So I've kept that term on the left, and the e to the power of 4x term is on the right. So differentiating x squared and integrating e to the power of 4x, we have these terms. So we'll see now that we had the product of two functions of x, we still have the product of two functions of x. So we have to do integration by parts to all of this again. So it's as though you rewrite this somewhere else. You do the integration by parts just for this, you get the result for this, and you bring it back and replace it here. So that's exactly what we're doing here. So pretend the bit in the left there, it's not there anymore, so I'm just going to cover that up. Pretend it's not there. Okay, so if we're doing integration by parts for this, you've got a half x, that's the x term, it should be on the left, which it is. We have the e to the power of 4x term on the right. You integrate e to the power of 4x, you get e to the 4x again, you divide by the coefficient of x, so that gives you a quarter. We differentiate half x to get a half. So then we do the same as before, we multiply these two and then minus the integral of the product of these two, like this. and now we have a single function of x right here, and we integrate this part. Okay, so these terms that I've just put in brackets, so this part here is the result of this. So we have a quarter x squared e to the 4x minus, and then I need all of this in brackets right after. So in here I'm going to replace this with this, and then when you expand the brackets, be careful with the sign there, that's a minus, and there's a minus outside, so we end up with this plus a constant of integration. Example 6, we have limits of integration this time. So to begin with, ignore the limits. So the x term is on the left, the e to the x is on the right, differentiate on the left, integrate on the right, and then apply the formula. So again, we're cross multiplying this way to get the terms here, then it's always minus the integral of, and then you multiply these two. We have a single function of x here, we integrate, and we get these terms. Now we can put everything in square brackets and put the original limits on, like this. Substitute in the limits, simplify. Example 7, integrating a natural log function. Now there's a little trick involved in this. To use integration by parts, you need two parts when you start, typically two functions of x. You can only see a single function of x. Ln x is a single function. It's not ln and then there's the x. It's like there's two functions multiplied. Yeah, ln by itself means nothing. Yeah, ln x is a single function. So what we do is we multiply by 1. You can think of that as x to the power of 0 if you like. So integration by parts, differentiate the left, integrate the right. Integrating 1 gives us x. Apply the formula, so ln x times x on this side, and then 1 over x times x gives us 1, so we're integrating 1, and then the final answer. So if we're integrating ln x, we get x ln x minus x. You should know this proof. Example 8, this is quite a challenging one. So e to the x sine x, differentiate the left, integrate the right, apply the formula, and you'll see we've got another two functions of x multiplied. So we do integration by parts again for this section in yellow, and that should be a plus there. We had a minus cos x times e to the x, and there's a minus the integral of in the formula, and the minuses give you a plus there. So just taking this section here, so e to the x cos x, and once again differentiate, integrate. So now we have this, and this minus e to the x cos x plus that we had before is right here, and again we've got a product of two functions of x. We were integrating e to the x sine x at the beginning, we had e to the x cos x at this stage, we're back to e to the x sine x here. So it's like we're going round in circles. So there's no point doing integration by parts again. We're just going to get another e to the x cos x term, then e to the x sine x again, and so on and so forth. So if we expand the brackets and rewrite the full problem so far, we have this. That was the original question there in green, and these are the terms that we've got so far. That minus e to the x cos x term is right there, e to the x sine x is here, and minus the integral of e to the x sine x is here. Now you'll notice that the term in green here and this term are the same. That's got a minus in front, so if I move this term to the left hand side, we get two lots of this, like this. Then all we need to do now is divide by 2 throughout, and the integral of e to the x sine x is a half e to the x bracket sine x minus cos x, and we can add on our constant of integration. For practice, try these questions.